Okay, here we are. All right. Welcome everyone to this afternoon's session at the day 3 of digital transformation in government. I'm here with Martin St-Yves, who's the CIO and Assistant Chief Statistician of Canada, Statistics Canada. He's the Chief Information Officer and Assistant Chief Statistician of the Digital Solutions field at Statistics Canada. He holds a master's degree in management sciences from l'École des Hautes Études Commerciales in Montréal. Throughout his career and for his last 6 years as CIO, Martin has provided strategic advices empowering the agency in modernization and ensuring efficient operations through innovative use of technologies and digital principles. As part of his achievements, he's led his team to deliver on the leading edge of data analytics as a service platform, a secure cloud ecosystem, a modernized cybersecurity program, and a successful census technology platform. I'll hand it over to you, Martin St-Yves, to speak on the topic of capitalizing the Canadian data ecosystem with analytics. Thank you.
Yeah, thank you. So good afternoon, everyone. I'm really happy to be with you today to talk about digital transformation, but with the data and insight lens. So I'm on to slide 2, and I'm going to kick it off with a quote from Mr. Edward Deming. Without data, you're just another person with an opinion. And Mr. Deming was a statistician who worked at the US Census Bureau in 1939. He's a recognized leader and thinker in the field of quality, and was a key contributor to Japan's recovery following the World War II. And it's quite interesting to see that, I mean, even though he died a long time ago, and this is an old quote, and the current context flooded with disinformation, I find this quote to be quite actual. So I think that most of you would agree that in today's world, every organization, public and private, is making efforts toward becoming data-driven. And there are good reasons for this. So just looking at the last couple of years, we can see that the pandemic has accelerated the socio-economic transformation of our society. The list of socio-economic challenges and issues is very long. Supply chain issues, the housing costs, which are on the rise, global warming, mental health. These days, we're talking about the impact of hybrid work on people, organizations, economy, violence against women, racial discrimination, possession of weapons, inequalities. So, and the list goes on. And such a fast-changing environment, public and private institutions, businesses, citizens all need to make quick decisions to deal with that disruption and to adapt. And this drives an urgent need for quality and timely information and insights. So if your organization is not discussing how to become data-driven, it's never too late. In fact, it's urgent. And I'm here today to share some ideas on how you can achieve this. So I'm going to be on slide 3. The good news is there are several opportunities organizations can tap into to support their data ambition. So I think you can flip the slide. It's not flipping on my side, but first, data is everywhere. Datafication has not made its way into the dictionary, but I would assume that most of you know what I'm talking about. At its core, datafication simply means that everything we do is being transformed into data. You browse the internet, you consume social media, you shop online, you walk in front of a camera, you use your credit card, you talk on the phone. All of our activities are leaving a data trace. And a few years ago, when cannabis got legalized, we started measuring socio-economic impacts of that legalization. And we found out that we were struggling and figuring out how we're going to measure the impact of cannabis. And we found out that you can measure cannabis consumption by collecting wastewater, since cannabis leaves a trace for a certain amount of time. And by collecting wastewater, we could measure consumption of cannabis and geolocalize it. So I use this example to capture the imagination. Like, data is really everywhere. And I'm a CIO of a statistical organization. So I have to share with you some statistics. The first one is from Statistics Canada, and it is from an experimental study we did a few years ago where we measured the value of data in Canada. And according to our estimation, the value of data in Canada in 2018 was near $220 billion. So an order of magnitude, this is roughly equivalent to the stock of all other intellectual property products, software, research and development, mineral exploration. To put that growing importance in perspective, the year before 2017, the stock of established crude bitumen reserves in Canada was just over $200 billion. We also measured the annual growth between 2015 and 2018, and it was estimated at 6.2%. This is 2% more than the annual growth in machinery and equipment and non-residential building. The other quote I've put on that page are not from StatCan, so I can't attest to their quality and accuracy, but they do demonstrate this datification trend. Whether we like it or not, we are data. And for organizations that want to become data-driven, it represents an opportunity. So we have data. The second opportunity is around technology. Over the last few years, there have been a massive influx of data technologies, open source and commercial, and that growth keeps going. Open source platforms like Apache Hadoop and Spark for storing and processing, data analysis tools like MongoDB, database platforms like Apache Cassandra, streaming platform like Kafka, visualization platform like ClickView and ShinyR, programming language, R and Python, AI machine learning models and libraries, cloud native platforms like Kubernetes and Docker. So, and this is just a subset. There are, I just went through a list of open source, but you have the commercial equivalent of all of these platforms. So, so there's never been such an offer of technologies. The challenge is not to find the technology. The challenge is to find the right one for your needs and then to develop and sustain the expertise to use these technologies. So we have data, we have technologies, and finally, if you take these by themselves, they do nothing because you need people. You need people that know how to use this. And the good news is there has been a significant rise of data science-related jobs, which has resulted in a growth in data-related learning programs. The data science community has grown drastically along with data science knowledge. Yes, there is fierce competition for resources, but there is definitively a growth trend. So we have the data, we have technology, we have people, we have expertise. So why is it so difficult to become data-driven? So I'm going to be on slide 4 now. Well, along these opportunities lie a number of challenges, and many of which we've never dealt before. I'm going to start with the 7V, or the 4V or the 7V, but the fact that data is growing at a massive scale is both an opportunity and a challenge. The systems and technologies we've built in the past, in many cases, cannot deal with that massive volume of data coming at us. And that volume does create technical and process challenges in terms of ingesting, processing, analyzing, modeling, storing, and visualizing. Most of that new data is being generated in unstructured fashions, which make it difficult to compare. Not only is the volume of data increasing, the pace at which that data is being refreshed in many cases is near real time, especially with the growth of sensors and IoT devices. Everyone is producing data, so this brings a challenge in terms of ensuring the data is trustworthy and has sufficient quality to base our insights on. Probably one of the least talked about challenge, but in my opinion, one of the bigger reasons organizations struggle is how do we transform data into value? How do we avoid costs getting out of control? How do we create proper return on investment for our data program? This has to be on the top of the list for our C-suite, Chief Data Officer, Chief Digital Officer, Chief Information Officer. Then there's the list, there's the notion of ethical use of data. Having the legislative framework to consume and use data is not sufficient. It can collide with other important considerations such as privacy and ethical use of data. We have to realize that most of us are creating data without consent. So a modern data program has to take into consideration that there's going to be trade-off to be done between what you can do and what you can do ethically. And I'll get back to it. Data collection is another challenge. So at Statistics Canada, surveys have been the primary mode of collection for many years, and they gave us high quality data, but it's more and more difficult to rely on surveys. There are challenges in contacting respondents. The days when you could find anyone through the yellow pages are long gone. People have pivoted towards social media as their primary mode of contact. And this brings new challenges. And then we must be worried about respondent burden. Yes, we have access in many cases, not all, to alternate source of information, but this brings complexity. To give you an idea of the evolution of data collection within my organization, many years ago, we relied mostly on in-person interviews, phone interviews, paper interview, and admin data sources. But these days, if we look at our collection toolbox, it's been digitalized. So we have web collection, crowdsourcing, web scraping, we use panel surveys, we consume scanner data, satellite data, sensor data, just to name a few. So really that collection has gone through significant digitalization. Privacy is another challenge, and for a statistical organization like ours that is based on trust, it is a key consideration. Citizens and organizations expect us to maintain their privacy, and it is critical in maintaining the trust. Confidentiality is different than privacy. For many organizations in the data business, ensuring that data remains confidential is a key requirement. And with so much data about us and advances in data science and technologies, it's no longer sufficient to remove identifiers from data, because if we're not careful, there is a risk of re-identification by linking de-identified data with other data. And we've seen incidents in recent years where anonymized data was linked with public data and re-identification occurred. So we must be worried about that. Security, of course, is paramount. And with the evolution and constant growth of cyber attacks, it is challenging to keep pace with cyber criminals. And to complete my list, which is not exhaustive, competition for data talent and the shift towards a data-driven culture are other important challenges. I will not cover them in the presentation because I want to stick within the time allocated to me. It doesn't mean they're not important. In fact, they're extremely important, but they would deserve a separate discussion. So I'm going to move to slide 5. So we've talked about opportunities and challenges. I want to dive into solution mode. How can an organization become data-driven in this type of environment? I'm going to start with a disclaimer. There are no silver bullets. I don't claim we have the perfect recipe. In fact, we don't, because there are unresolved challenges. So I'm here to offer the perspective of an organization that's been dealing with data for more than 100 years, an organization that has been measuring the transformation of society through socioeconomic lens, and an organization that's been forced to transform and digitalize its business model at the same pace as society evolves. Otherwise, we would become irrelevant. So I'm here to invite a call to action. I'm here to tell you that there are concrete solutions to many of these data challenges, and that we can take action now. We can all pivot towards being data-driven. It's okay to establish a vision. It's okay to establish a strategy and an action plan, but the world is not waiting for us. It evolves and we need to act quickly. So it's really a call to action that I want to communicate. So let me offer you my perspective of what it takes to become a data-driven organization in today's world. And it won't be an exhaustive list, but when I was thinking about it, these are, in my opinion, some of the essential enablers. And I got this triangle here. By the way, if you look at this triangle, I don't think you'll find this triangle anywhere. It is a representation of how I personally think about the pillars of a data program. It's not an industry framework. There's different ways to represent it. So I'm going to start with the top technologies and digital principle, which is a natural fit for me as a CIO, giving my background and experience. But the reason I'm going to start with this one is that, in my opinion, this is usually what organizations tend to focus on. And I believe it's the easiest and most mature of all of these pillars. So, of course, in order to capitalize on data opportunities, tackling some of the challenges I mentioned, any modern data program will need access to modern technologies. Cloud is a critical enabler for its ability to scale on demand, for its pay-per-use model, for its access to a continued offer of modern data capabilities through IaaS, PaaS, and SaaS, and for many other reasons. Cloud ensures that technology is not a constraint, but a resource that you can consume on demand. You also, in a data program, you will also need to leverage technology to enable modern data analytics capabilities, from ingestion to analysis, modeling, collaboration, visualization, and much more. Data scientists and data users will want access to modern tools in a self-serve mode, and your technology platform must support this. And it's also essential to embed digital and architecture principles like open by default, accessible from the start, secure by design within that technology layer. And the other dimensions, which I'm going to talk about, the other pillars, also need to be embedded within that technology platform. I'm going to get back to it a bit later. The second layer is data stewardship. And you will need to consider and implement appropriate data stewardship principles to ensure data is accessible, usable, safe, trusted, and fit for use. I have a slide that's going to talk about it because, you know, data stewardship for many means different things. So I'm going to try to provide the definition. Data science is another critical pillar. Traditional methods are no longer adequate to deal with the characteristic of our data ecosystem and to offer the agility required. At StatCan, we currently leverage data science in a number of our data programs. We do predictive analysis, data engineering and pipeline, natural language processing, PDF extraction and optical character recognition, image processing, privacy preserving, metadata management, chatbot, web information retrieval. We have a number of research projects around quantic, homomorphic encryption, and many more. So it's really embedded within all of our data program. And it's being used every day. We currently, we're just coming out of a census, so we currently leverage natural language processing to classify census respondent comments into subject matter or general census themes. We make extensive use of data science automation techniques to ingest information. We use data science modeling to analyze data from the Canadian Coroner and Medical Examiner database to detect new pattern of death. We leverage data science optical character recognition to transform PDF information from companies' financial statement into data. We leverage data science technique to apply privacy preserving techniques to data. For instance, we have a program where we're measuring cyberbullying, so you'll understand why it's critical to protect privacy of the input data. We leverage data science to analyze satellite information and so much more. The next pillar is data partnership, and a favorite quote of our chief statistician is, "Data is a team sport." No organization, even a national statistical organization, owns all data and has all the data. So we must leverage data partnership. And it's not limited to federal organization. It's all public and private institution. Of course, taking into account the challenges associated with data sharing. And the final pillar I'm proposing, which to me is the most important one, is subject matter expertise. And so what do I mean by this one? Because I must admit I struggled to find a label that clearly communicates this pillar and that fits within the triangle. So essentially what I mean here is that any data initiative must start with a purpose, a question to answer, a problem to solve. In order to move from a solution framework to a concrete action, we need to clearly understand what's the problem, what's the question that we're tackling, what subject matter expertise do we need? And again, I'm going to get back to it. So moving on to slide number 6, I won't go into the details of each pillar, but I thought this audience may be interested in a couple of these pillars, and I'm going to start with technologies. 5 years ago, as the CIO, I established a digital vision, strategy, and roadmap for our organization to support our agency modernization agenda, which is centered around data and insights, since we're the national statistical organization. And the strategy was built around 3 pillars: digitalization of our services, digitalization of our toolbox, because if you're going to digitalize your services, you need a toolbox that's going to allow you to do it, and digitalization of people and processes, because again, like if you're going to use a digital toolbox, you need the people that know how to use that toolbox and the processes that come with it. The analogy that I'm going to use is, if you want to pivot from analog to digital, from paper to electronic, you need a different set of tools, and your people will need to learn new skills and techniques. As part of the digital services, the key one was to engineer and deploy a modern data analytics platform, one that would be open, flexible, modern, scalable, self-serve, virtual, secure, private by design. I'm into the next slide, by the way. So it's slide number six. And we've delivered this platform, which we call the Statistics Canada Data Analytics as a Service Platform, or DAS, to keep it short. So what is it? It's a 100% cloud-native platform that offers a range of data capabilities to a range of personas or user types, both internal to StatCan, federal partners, and also to external users and partners, including academic. The platform sits on our StatCan Secure Protected vCloud. This slide shows some of the capabilities that are offered, grouped around account management. So it's the ability to onboard internal and external users and to manage their identity and credentials. There's a group of functions to explore the data. So ability to access a range of data sources and data standards through a metadata data search engine, from open to micro data, StatCan data, crowdsourced data, partner data. There's a set of capabilities to ingest and store the data. So from traditional secure FTP to support for modern data ingestion pipeline, APIs to access the data externally. We have cloud-to-cloud transfer. This is supported by both open source and commercial data storage and processing capabilities. At the core are the capabilities to analyze and compute. So there's a number of capabilities, all available through a self-serve and auto-scale survey delivery model. So to give you an image, a data scientist can log into the platform and can self-provision a data science notebook with a range of data science tools, Jupyter Notebook or Python, can specify the type and quantity of compute they need, CPUs, GPUs, storage, and behind the scene, we containerize an environment for that data scientist that is safe to work with, that will auto-scale as required. And throughout the platform, there's a number of open source and commercial tools available to visualize the data and create compelling story. There's also geomatic capabilities that are not on this picture because, if you're going to be analyzing data, you're going to want to map it out on geomatic. And the platform is fully virtual, can be accessed anywhere, anytime, any device. So we wanted with this platform to make sure that our users would have the tools and that technology is an enabler. Moving on to the next slide, slide number 7. This is another view of the platform. This time it's a product view. So it shows the capabilities to the left by product line. Because the way we've engineered the platform is we actually spend the first 90 days talking to people, talking to data scientists, data users. We created personas. We've asked them, what was their user journey? And based on that, we started identifying capabilities and we engineered them as Lego blocks so they can be assembled into a product for a specific need. So for instance, the first product is called AEW. It's the Advanced Analytic Workspace. This is for data scientists, both internal and external. So it's a 100% cloud native open source platform. I recall before we deployed this platform, I had a chief data scientist coming to me telling me, I'm losing data scientists, Martin, because we can't offer them the tools they need to do their job. So they're going somewhere else. And now these same data scientists are saying, we got the dream platform here. And they're actually co-creating and evolving the platform with us. So the second product offering, similar capabilities, but to a different audience. These are advanced data user. So this one leverages commercial cloud, SaaS, and PaaS offering to provide the same capabilities, but in an easy to use interface. So you can still create data ingestion pipeline, but you'll do it using an interface. Virtual Data Lab is another similar offering, but this one is for external researchers across Canada. So similar capabilities, but there's a slight variation in the configuration. The last one I'm going to mention is called Optimus on this slide. Don't like the branding here, it's going to be changed, but this one is intended for our citizen developers. Everybody's in IT these days. At StatCan, we got 6,000 employees, 3,000 of them are citizen developers. So through DAS, we wanted to offer a modern, well-supported and controlled platform with some built-in guardrails to ensure that their work would maintain appropriate security, maintainability, robustness, and adequate support. So this is just a taste of the platform. It's still evolving. We've deployed the first iteration of this platform back in April 2020, right at the start of the pandemic. And as of March, we had over 1,100 registered users. 300 of these are external. And by the end of this fiscal, we'll be well over 3,000. We have over 140 data providers and stewards, internal and external, that are leveraging the platform. We have 13 partner departments collaborating on the platform. And we measure user satisfaction, and it sits at 85% for a platform that, we're still in development mode, which is quite good. Moving on to the next slide, slide number 8. This one is about data stewardship, another key pillar. What I'm sharing with you is our definition of data stewardship on the placemat. What you see there are a set of practices to ensure that at the end of the day, data is accessible, usable, safe, trusted, and fit for use. And in the interest of time, I won't go into the details of the placemat. If you're interested, you can contact me and we can have an offline discussion. I just mentioned a few important dimensions of data stewardship that may not always be obvious. Data standards are super important. You should always seek to use data standard. It's easier to do it from the start, but it's never too late. Now, navigating through data standard can be a daunting task. I'll get back to it because I have some advices, but note that there are some organizations like StatCan that publish data standards through API. So, there are ways to consume data standards. Data quality is a challenge with big data, and data science techniques offer ways to help here. So one important point I want to make with these pillars I presented earlier, technology, data stewardship, data science, is they need to be interconnected. None of these pillars by themselves are sufficient to build a data program. You need all of them, and they need to be integrated. So if you take, for instance, data protection and that placemat, and you take privacy, we have created at StatCan a privacy framework with 10 privacy principles that need to be part of any data initiative. When we've built the data analytics platform, we made sure that these principles were either embedded within the platform, so that by using the platform, you inherit the privacy principle, or when not possible, we made sure that the platform offered capabilities for user to enable these privacy principles. And the last thing I wanted to mention was to navigate the complexity of ethics, privacy, and needs. We have created a proportionality and necessity framework. So in simple terms, for every data project, we must demonstrate that there is a clear need and that we will only use the data that is required to meet these needs, no more. Even if we have a legislative framework like the StatsCan Act that gives us the authority to use the data. And the final point is data sharing is key. It's often mentioned by organizations as one of the biggest challenge to becoming a data organization. These are data silos. So start breaking these silos inside your organization. It's not always easy, but it pays off. Moving on to the last slide. So I want to bring all of this together. So we talked about the need for organization to become data-driven. We talked about opportunities and challenges. And I presented a solution framework with, in my opinion, some of the most important key enablers of a data program. So how do we turn this solution framework into concrete action? How can we respond to this call for action from the clerk? I will start by saying that from my experience, the #1 challenge that organizations face is a poor understanding of the problem or question to answer. It can be tempting to jump right into this ocean of data, right into the tech. This is a recipe for failure. And it may result in cost overrun because we're going to consume more data than we need. We're going to need more compute than we need. It may result in not having the right data partnership and not having the data that we need, and then duplication of data because we're going to start collecting data that there may be a partner out there that already has that data. It could result in risk of privacy issues because if you have a weak case for consuming data that is sensitive, we may get in trouble. And I could go on and on. Suffice to say that, in my opinion, the most important best practice I can suggest to start with is a clear understanding of the problem or question and a clear business case. So as a result, in order to turn that framework into action, I'm proposing that, and there's a bit of animation here, so just one click, I'm proposing that we turn this solution framework upside down, and we start with the subject matter pillar. This is the first ingredient that I would put in my recipe for cooking a good data program. We need to focus on this one. Like, we need focus, we need purpose. Because as we climb through the framework into data partnership and data science and data stewardship and technology, we can quickly find ourselves buried in a massive amount of concepts, standards, tech, and data. As we better understand the problem statement and we start to define the units of measurement, it's going to help us understand what data is needed, what are the data gaps, and navigate through that framework. To me, a well-defined problem statement will give us clues as to, what are the data partnership that we should be looking for. So once we have the problem well-defined, we can start establishing the data partnership, because now we have a good idea about what are the gaps and who are scanning our ecosystem of data partners who would have data that could be relevant to us. We must avoid at all costs to try to collect or ingest and first seek data partnership. So once we have the problem well defined and the data partnership established, then we can leverage the other three pillars to execute on our data program, which are data science, data stewardship, and technologies. They're so integrated that, to me, I treat them as a package. So we have defined our problem or the questions. We've identified our data partners. We still have these challenges, which I talk about, the 7 view of data, data protection, ethical use of data. And this is where we leverage data science and technologies to do that ingestion, consumption, analysis, modeling, and visualizing in an agile way. And then supported by modern technologies, and we apply proper data stewardship techniques. So I really want to show you that this is not a theoretical solution framework. So I'm going to conclude the presentation with a few real examples of situations where we've leveraged these pillars for the benefits of Canadians. So just looking for time. Okay, so I'm going to start. I have lots of examples, but I think there's about 8 minutes left. I'm going to start with some examples where insights were needed urgently to answer important and in some cases life-threatening questions and problems. And I know you're probably tired of hearing about COVID, but I have to start with some examples related to COVID. The first example that comes to mind happened very early in the pandemic when we started running out of personal protective equipment. Remember the shortness and supplies of gloves, masks, and other protective equipment. That situation was life-threatening, and the government needed information to deal with it. So information and insight were required quickly and with sufficient quality, because at the end of the day, we're dealing with the lives of people here. So as I'm suggesting with that solution framework, we did not jump into our existing data source, or worse, started collecting new data, nor did we jump into our tech platform to start running analysis and dashboard. We brought together subject matter experts to better define the problem. So what's the problem statement? Who are these subject matter experts? What are we measuring? What questions are being asked? What information is required to answer these questions? Who's interested in these questions? That's the critical first step to give you focus and to turn that framework into action, because it's going to help you navigate through these important dimensions. So for this use case, personal protective equipment, I'm going to bring you back to March 2020, the beginning of the COVID pandemic. The main story in Canadian media, besides running out of toilet paper, was centered around the need for personal protective equipment, or PPE, and the lack of supply in Canada. So a team of subject matter from various organizations was assembled, and the following questions were defined. How much PPE did we order and deliver? How much PPE do we need, and will we have enough? And finally, what step can we take to ensure optimal use of our stock? Based on that, we were in a position to understand what are the units to be measured, what data do we need. And so it helped us identify data partnership. In that case, partnership were formalized through MOUs between Health Canada, the Public Health Agency of Canada, Public Service and Procurement Canada, Innovation Science and Economic Development of Canada, and StatCan, and provinces and territories were also engaged. Moving into data stewardship, we leveraged existing legislation with the Stats Act to implement proper data stewardship, because the data was coming from various organizations. And these data partnerships allowed us to leverage near real-time data, greatly improving the quality and accuracy of information while reducing respondent burden and overall data collection cost. All aspects of data stewardship that you've seen in that placemat were considered, so I won't go into details on all of them. Just mention a few. Data quality. Well, the fact that we leverage data from recognized partner ensured a certain level of quality, and we've added some statistical methods to measure quality. Data standards, we created data standards where none existed, and they were needed. And we published and pushed these standards to all partners so we can quickly compare the data. Practical example, how do you define a glove? So there was no definition for gloves. So we created a standard to define gloves so we can all speak the same language. Given the variety of data sources, governance was established to manage permission and access to data. And to support data sharing and access, we leveraged our data analytics platform as a service. It comes with a strong metadata search engine API. So we made sure that the information was findable, accessible, and could be consumed and reused. Moving on to data science. In that case, data science techniques were used to facilitate and automate the ingestion of data. So we created the ingestion pipelines to ingest and curate the data. And we leverage modern data visualization dashboards to tell stories that people could understand, non-expert could understand, and we made these stories available to partners and users. We've also built through data science epidemiologic models to forecast the trajectory of the COVID outbreak and provinces to estimate the protective equipment demands in various sectors across the nation. So as for the outcome, this data problem using traditional method would have taken months, but leveraging the solution framework, we were able to produce insights within only a few weeks. And this was done extremely efficiently. The first deliverable I recall, was of the project was to answer the first question. So it was a dashboard that showed the status of procurement and deployment of every PPE commodity. So it answered the first question: how much PPE did we order and delivered? And this dashboard initially was updated daily and was used for reporting to the Minister of Health and to PCO. In order to answer the second question, which is how much PPE do we need? Will we have enough? And where should we send that equipment? We worked with Health Canada to develop the PPE demand and supply model. So we integrated supply data from the first dashboard. We've added demand for different segments of the economy, healthcare and non-healthcare. And then we took our epidemiologic model along with PPE survey data, analytical research, and we use that together to provide insights into how to ensure that there would be enough protective equipment in alignment with the evolution of the pandemic. But again, like the initial time spent defining the problem paid off because it helped us navigate quickly through that solution framework. There were a lot of similar examples of COVID-related data programs where we applied that solution framework with great success. Just quickly, there were questions related to the impact of COVID on travel. This triggered the need for a weekly aircraft movement program. So we established a partnership with NAFCAN. We use data science and DAS to produce timely and granular information to help understand the impact of COVID travel restriction on the aircraft movement, initially in the 41 major airports in Canada and eventually in all flight service stations. There are still questions on the impact of COVID on businesses. So we partner with the Canadian Chamber of Commerce, who's interested in understanding what's the impact of COVID on businesses. So, and there's a lots of examples related to the pandemic. Moving on to a different set of use cases, I'll talk about our agriculture data program. And I have a few interesting examples here of how we leverage the data solution framework and the ag domain. So we all know how busy farmers are. So surveys and respondent burden have always been a challenge with the farmer community, which often leads to data quality issue, especially when you ask a farmer very detailed information on what they produce, what they consume, all of that. So looking at the opportunity of big data, coupled with advancement in data science and our technology, we launched an initiative a few years ago that we called Ag Zero. Essentially, the objective is that we're going to pivot the agriculture program to a point where we need zero interaction with the farmer. So we use landscape satellite imagery and provincial crop insurance data. And through deep learning techniques, we're able to provide near real-time estimates of crop area within Canadian provinces throughout the crop season. And this is done with no burden to the farmer. In the same context, we use rapid eye satellite images to locate greenhouses. And we apply data science techniques and models like neural network or UNet for the expert in the room to convert these images into data. So just gave you a couple of examples of new program. The final example I want to use is we also leverage the solution framework to streamline existing programs. So the example I want to share is our Frontier Counts program. This is a data that's been counting number of visitors entering Canada since 1920. The data is collected by a partner, CBS in that case, but under different programs and different formats and aggregation. We use this data to produce monthly statistics of visitors entering Canada, but the data also feeds our other important economic program. And being an old program, it's been engineered over time with traditional approaches for ingesting the information, cleaning it up, coding, imputing, estimating. And all of this is done through custom code being executed on traditional infrastructure. The program produces what it has to produce, but it's rigid, it's complex. It relies on lots of manual intervention and correction, and it needs to be updated whenever there are changes to data changes. So our teams leverage data science and modern technologies and approaches to significantly streamline that program. We automated the ingestion of information through data ingestion pipeline based on machine learning, so it can adapt to changes and data input. We leverage open source tools available to our data analytics platforms like Mini.io, Elasticsearch, Kibana to make it fully scalable. Within the platform, our data scientists and data users leverage tools like Git for versioning and collaboration. There's lots of citizen development embedded into these programs. And they pivoted toward the DevSecOps model so that we can do a continuous release of new capabilities or patching. And this program was completely rebuilt with a small matrix team of citizen developer, data scientists, and IT folks. And we spent, I think it's something like 4 FTEs to completely revamp the program. And so above and beyond, the fact we were able to do this, now it's bringing lots of operational gains. The program will self-adjust to changes in the data input automatically. The compute and storage capacity is no longer constrained. Thanks to cloud and cloud-native approaches, it's going to scale up and down as required. If needed, we can quickly deploy new fixes, patches, capabilities, because we are leveraging CI/CD pipeline. So our time to market has been improved drastically. We have built-in redundancy now because the underlying environment is all software defined. So it's infrastructure as code. So if there's a disaster, we push a button, everything gets rebuilt. And the list goes on. So I'm going to stop there. I have lots of examples. I did not cover all of the examples that you see on the screen, but I'm going to leave you with 3 key messages that I'm going to repeat that I spoke about in the presentation. We have the technologies and methods to support data-driven decision-making. So let's not get stuck on the vision and strategy. Let's not get stuck into technologies and wires. We can act. The second one is data as a team sport. Stop owning, start sharing and collaborating. And the final one, it all starts with subject matter. It all starts with taking the time to understand the problem or questions. On that, I'm going to stop there. Thank you all. Merci beaucoup.
Merci, Martin. Words to live by. Thanks very much for that presentation. Sorry for the anomalies with the slides. It's not something that I've been doing typically, so hopefully it wasn't too bad for everyone who's experiencing some issues at the start. Okay, so we have a question. What does Stats Canada think about the new data collection methods like crowdsourcing? Are there any plans to utilize such tools?
Well, absolutely. I think I mentioned as part of the digitalization of our data collection toolbox, we do leverage crowdsourcing. and web scraping as well. So again, like all of these techniques, they come with challenges. It's not because you can do it that you should do it, but yes, they have to be part of your toolbox. I think that it's and today's age, like I'll give you an example. It's not so much an example of crowdsourcing in that case, but we produce the consumer price index. You got inflation. The way we were doing it 5 years ago or 7 years ago is that we would send our interviewers with a little device, and CPI is built on a basket of commodities. So we would send them and they would collect prices. They would go to grocery stores and, in the basket you got TV. So, they would go into, Best Buy or whatever they are. But think about it. So now what we do is that the stores have scanner data. Instead of having an interviewers enter store collecting the data, they're giving us the scanner data. So we completely eliminate human errors. And we also do web scraping. So we can go and we can browse the website to figure out what's the price of the TV. Now, that in itself is not sufficient because you got to be able, if you take TVs, for example, the TV that existed a month ago may not be the same TV, but so you have to also look at the characteristic. So, in today's age, it's not about are you using surveys or web scraping or crowdsourcing. It's about are you leveraging this entire toolbox of collection tools to be more agile, to be more efficient, to reduce burden, but you also have to consider privacy and ethical use. So
excellent. Okay. Well, we don't have any other questions, so just a reminder: if you have any questions, you can input them into the Q&A section. I guess you mentioned a little bit about continuous as the CI/CD pipeline, and that you've introduced that. That's phenomenal and great. I guess one of not to sort of stump you or anything, but I guess Stats Canada is known within government Canada to have most data scientists, and that's for sure. And I guess perhaps how do you deal with the issue? Maybe trying to come up with a single source of the truth. So if there's a question that you're asking and you hand that off to 12 different data scientists, is there what ways or what do you think about having to deal with that to try and narrow down to having one version of the truth?
I'll be very humble here. I don't think I'm the best person to answer that question. I wouldn't do an attempt at answering your question. It is a very important, it is a very complex question. We can follow up online, but I don't want to attempt to answer that question because I think it's going to take more than 5 minutes, and I'm probably not the expert in that domain.
That's very fair enough. Thank you for saying that. And sorry about pressing you like that. I guess we've talked about COVID. We've talked about some practical applications from the framework and its action. I guess what do you see as being the things that you're probably going to be wanting to address, I guess, over the next year at Stats?
You mean in terms of thematic or the evolution of the framework?
Yeah, evolution of the framework or introducing capabilities or mature capabilities you may not have right now.
Yeah, so I would say that 3 years ago, so I think I said that at the beginning of the presentation that 5 years ago, I established a digital vision and strategy. Lots of excitement, we're going cloud first, blah, 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 all of that. Then you turn into execution mode. And the challenge we have in the IT domain is, when you're building large platform, to maintain the excitement of your sponsor, it's difficult to go on the 2 years, we're going to be developing a platform and you get access to it in 2 years. So we really embedded the digital principle from the get-go. We wanted to start deploying capabilities, even if they were not perfect, very early on. And we wanted to make sure that what we would develop, we really adopted the private sector mindset, would be the things that are needed the most. So that's why the way we started the development of our digital services and toolbox was user-centric. We consulted the users and to find out what do they need to operate in today's world. And from this, we started saying, okay, data ingestion is key because, there's so much data, it's coming at such a fast pace that, writing your little, a SaaS widget, like it's not going to work. So we need, so they're going to need data ingestion pipeline. So we started collecting the capabilities that are required and then putting them on a product roadmap with, we wanted initially to do releases every 3 months. So where came a point where we had enough capabilities, enough of our, enough cloud maturity, enough technology capabilities, enough data stewardship expertise, and enough data science expertise to actually start actioning some real problem. But we're still learning. We're still, 5 years ago, we had, a cloud team of, I managed about 1,000 IT professionals, but, the cloud expertise was, about 15 people. Now it's, now it's about 250 people. So, I'm making a call to action because we have enough capabilities and technologies and science to be able to tackle any data problem. Now, we're not done. There's still a lot to be done. Some areas that are more complex is, okay, so your organization X, you have information that could be of value to us, but it's very sensitive and you're not willing to let us ingest that information, even if you maintain data stewardship of that information. That's why we're looking at things like homomorphic encryption. Are there techniques that would allow us through technologies to link information without ever seeing the information? So it's kind of where we are in terms of evolution, because the model of bringing all the data into one location doesn't work. But the way in which we're going to do it, coming back to my triangle, is based on need. So right now, most of the data programming needs we can support. You got the odd case where someone is coming out something and we're missing a capability. And then we look at our product roadmap and we see, okay, can we fit it into the next release? Is the industry ready in terms of maturity to tackle this one? So we make these calls, but it's really just like, these digital principle, it's iterative, adaptable, but it's user-centric. We're looking at what's needed, and then we're prioritizing our resources and our work based on what's needed, instead of just coming up, with here's the capability roadmap and build it and they will come. So, that field of dream, we're trying to avoid it.
That's good. Hearing a lot of great things from you today. Thank you very much for presenting today. It's been fantastic. I think we're close to time. There was another question. I'm not sure if you want to try and tackle it. The open source data is a challenge. It's available for collection, but not necessarily usable for the purpose, given concerns about privacy. How can we develop a culture of responsibility in the use of data that is self-governing?
Yeah, I won't have time to answer this one.
Okay.
Like, if you browse the internet and you look at the big data challenges, often culture is going to come up as the number one. That's why I started saying it's important, but it's such a big dimension that I probably won't have time to cover it in the little bit of time that we got left. But
sure. And just previous to this stream too, we had some discussion about trusted data as well. So went into a little bit more into detail into that. But if viewers wanted to review that video, that's available as well. Well, thanks again very much.
My pleasure.
Thank you very much, Martin, for coming. It's been a pleasure, and I very much appreciate the presentation.
Thank you very much. Have a good day.
Thanks. Take care.